RAG indexing retrievers. Overview. Description. Retrieval augmented generation RAG combines the power of information retrieval and generation models to enhance the performance of language models. RAG indexing retrievers are critical components in this framework, responsible for efficiently indexing and retrieving relevant documents or passages to augment the generative process. Key components. Indexer. Description. The component responsible for indexing a large collection of documents or passages. The indexer transforms raw text data into a searchable format, often using techniques like tokenization, embedding, and storing metadata. Retriever. Description. The component that searches the indexed data to find relevant documents or passages based on an input query. The retriever uses various algorithms and models to perform efficient and accurate search operations. Encoder. Description. The neural network model that converts text into high-dimensional vectors embeddings to facilitate efficient retrieval. Common encoders include BERT, RoBERTa, and other transformer-based models. Types of retrievers. Sparse retrievers. Description. Traditional retrieval models that use sparse representations, such as TF-IDF or BM25. These models rely on keyword matching and are effective for exact term matching. Dense retrievers. Description. Modern retrieval models that use dense vector representations embeddings for text. These models leverage neural network encoders to capture semantic meaning and perform similarity search. Hybrid retrievers. Description. Combined approach that leverages both sparse and dense retrieval techniques to improve accuracy and robustness. Hybrid retrievers often use a combination of TF-IDF BM25 and embedding-based search. Steps. Step 1. Description. Data preparation. Collect and pre-process the data to be indexed. This involves cleaning, tokenizing, and segmenting the text data into manageable chunks or passages. Step 2. Description. Indexing. Use the indexer to process the prepared data and create an index. The indexer generates and stores both sparse and dense representations of the text data. Step 3. Description. Query encoding. Encode the input query using the same encoder model used during indexing. This step converts the query into a high-dimensional vector for similarity search. Step 4. Description. Retrieval. Perform a search operation using the retriever. The retriever compares the query vector against the indexed vectors to find the most relevant documents or passages. Step 5. Description. Context augmentation. Extract the retrieved documents or passages and use them to augment the input for the generative model. This context helps the generative model produce more accurate and relevant responses. Step 6. Description. Response generation. Pass the augmented input to the generative model to generate a response. The model uses the additional context to improve the quality and relevance of its output. Considerations. Index size. Description. Manage the size of the index to ensure efficient retrieval operations. Large indexes may require distributed storage and search mechanisms to maintain performance. Retrieval accuracy. Description. Optimize the retriever to balance precision and recall. Ensure that the most relevant documents are retrieved without missing critical information. Latency. Description. Minimize the time taken for retrieval and generation to ensure real-time interaction capabilities. This may involve optimizing the search algorithms and using efficient data structures. Scalability. Description. Design the system to handle large-scale data and high query volumes. This includes distributed indexing, parallel retrieval, and load balancing mechanisms. Relevance feedback. Description. Implement mechanisms to gather and incorporate user feedback to continuously improve retrieval accuracy and relevance. Technologies. Indexing engines. Description. Tools and frameworks for creating and managing indexes. Examples include Elasticsearch, Apache Lucene, and FAISS Facebook AI Similarity Search. Embedding models. Description. Pre-trained neural network models for generating dense vector representations. Common models include BERT, RoBERTa, and sentence transformers. Search algorithms. Description. Algorithms for performing efficient similarity search and retrieval. These include brute force search, approximate nearest neighbor and search, and hybrid search methods. Integration. API integration. Description. Use APIs to integrate the retriever with other components, such as the generative model and data sources, ensuring seamless data flow and interaction. Continuous monitoring. Description. Monitor system performance, including indexing and retrieval times, to identify areas for optimization and improvement. Feedback loop. Description. Incorporate user feedback to refine retrieval criteria and improve the relevance and accuracy of the retrieval augmentation process. Example usage. Enhanced question answering.